हेलो स्टूडेंट्स। हम पिछली क्लास में पढ़ रहे थे कि SN1 एविडेंसेस ऑफ SN1 मैकेनिज्म। आज हम उसी का ही कंटिन्यूएशन करेंगे। तो उसमें नेक्स्ट क्या होता है, द रोल ऑफ आयन पेयर्स। ओके, द स्टीरियोकेमिस्ट्री ऑफ SN1 रिएक्शन डिस्कस्ड above is easily understandable if the heterolysis in its rate determining step follows the following order। तो SN1 रिएक्शन में जो रेट डिटरमाइनिंग स्टेप है वो हेटेरोलिसिस रिएक्शन अगर इस फॉलोइंग स्टेप्स को सीक्वेंस को फॉलो करेगा तो हम इजीली क्या कर पाएंगे, उसको अंडरस्टैंड कर पाएंगे। तो इसमें क्या होता है, देखिए, हियर आई इज एन इंटीमेट। ओके, हियर आई, व्हाट इज इट? इट इज एन इंटीमेट contact or tight ion pair. It is a contact ion pair because here the cation and the anion are plus and X minus are not completely detached from each other. They are in contact with each other. So it is called what? Contact or tight ion pair. Okay, 2i, a solvent separated ion pair. Here in between these two ion pairs, what is present? Here the solvents are shielding the ions. Okay, and third, the dissociated ion, each surrounded by solvent molecules. Okay, these are completely dissociated from each other, which are being surrounded by the solvent molecules. Okay, in I and 2i, X minus is called the counter ion. Here X minus and here X minus is called as the counter ion. Okay, the reaction in which the intimate ion pair recombines to give the original substrate referred to as internal return। तो इसमें यहाँ पे क्या बता रहा है, अगर एक रिएक्शन में वो जो इंटीमेट आयन पेयर है वो रिकम्बाइन करके फिर से वही वाला रिएक्टेंट हमें दे रहे हैं, मतलब आर प्लस एक्स माइनस रिकम्बाइन कर जाएंगे और हमें आर एक्स मिलेगा। तो उस वाले रिएक्शन को हम क्या बोलेंगे? दिस इज कॉल्ड एज इंटरनल रिएक्शन रिटर्न। ओके, इंटरनल रिटर्न। द रिएक्शन प्रोडक्ट can be formed by the attack of nucleophile at any stage. In the 3 stages, there is a chance of the formation of the reaction product if the nucleophile attacks. Okay, then the intimate ion I is likely to lead to inversion as the attack can take place from the back side but not from the front side, which is shielded by X minus। तो जो इंटीमेट आयन है वो आई में क्या होगा, इन्वर्सन का चांसेस ज़्यादा है, इन्वर्सन ही होगा क्योंकि ये क्या है, यहाँ पे एक्स माइनस क्या है, कंटैक्ट आयन है, ये कम्प्लीटली डिपेंड नहीं हुआ है, तो दिस विल शील्ड द फ्रंट साइड। ओके, देन इफ द न्यूक्लियोफाइल is going to attack, it will attack from the back side, so inversion will occur। Okay, complete inversion will occur। Okay, attack in 2i is more likely from backside leading to racemization, whereas attack in 3i can takes place in equal facility from either side। Okay, so 2i, in 2i the attack is also from the backside, from front side, that is a very little chance of the attack from the front side, so racemization will occur। And here the R plus is completely departed from X minus, so here what the nucleophile will get the chance to attack both from the front side and from the back side। Okay, so thus as we proceed from I to 3i, the degree of racemization increases and proportion of inversion decreases। ओके, जब हम I to 3i तक जाएंगे तो क्या होगा, degree of racemization will increase. Okay, the proportion of inversion will decrease because X minus is gradually detaching from R plus. Okay, as the stability of R plus increases and the power of attacking nucleophile decreases, the proportion of third eye increases. ओके, अगर R प्लस का स्टेबिलिटी इंक्रीज हो जाएगा, मतलब R प्लस कैन बी stabilized alone. Okay, the power of attacking nucleophile decreases. इन R प्लस क्या होगा, स्टेबल हो जाएगा, पर जो हम न्यूक्लियोफाइल उसको अटैक करने के लिए यूज़ कर रहे होंगे उसका अगर क्या होगा, अटैकिंग पावर नहीं होगा तो क्या होगा, R प्लस if it is stable then it will stand alone. Okay, then R plus will form, which means we will get a third eye. Okay, then here is the next evidence, formation of rearranged product. Okay, rearrangement is one of the characteristics feature of carbocation. Okay, this is a characteristic feature of what, carbocation. Okay, because of strong correlation between rearrangement and formation of carbocation, rearrangement is often taken as indication of an SN1 mechanism, which are frequently accompanied by rearrangement. Okay, rearrangement is not the direct evidence, it is the indirect evidence, which means in SN1 reaction हम बोल रहे हैं कि क्या फॉर्मेशन होगा, कार्बोकैटायन फॉर्मेशन होगा. हम ये जानते हैं कि कार्बोकैटायन बनने का एक बहुत बड़ा एविडेंस क्या है, रीअरेंजमेंट. कार्बोकैटायन अगर एक स्टेबल कार्बोकैटायन बन रहा है तो वो रीअरेंज करेगा. ओके, दैट मीन्स इफ रीअरेंजमेंट ऑकर्स देन कार्बोकैटायन विल बी डेफिनेटली फॉर्म्ड. If carbocation is formed, then the reaction mechanism will be SN1 mechanism. Okay, and then here is an example where first a carbocation is formed, then it is rearranged to give the rearrangement carbocation, then the nucleophile attacks the C plus, the cationic center, then we get two products. One is the normal product, which is being formed from the primary carbocation. Primary means the first carbocation. Here primary means not that primary. Okay, and then the second product we will get from the rearranged carbocation. Okay, so it is called rearranged product. Okay, in general there is greater number of byproducts in case of SN1 reaction as compared to the SN1, which is a one-step process involving no intermediate, hence does not undergo rearrangement. ये क्या बोल रहा है कि SN1 रिएक्शन में हमें क्या मिलेगा, बहुत सारे बाई प्रोडक्ट मिलेंगे, greater number of बाई प्रोडक्ट मिलेंगे. दिस इज because here carbocation is formed. If carbocation is formed, then rearrangement will occur. So we will get more number of rearranged products, which are called what, byproducts. Okay, और SN2 रिएक्शन में byproducts नहीं मिलेगा. क्यों? क्योंकि this is an one step process. Okay, there is no chance of formation of carbocation and rearrangement, so we will get only one product. Okay, in fact the formation of different products from a single substrate in a reaction which follows the first order kinetics is a classic evidence that the reaction is proceeding through an intermediate. Okay, it is says the formation of different products from a single substrate. एक सिंगल सबस्ट्रेट से डिफरेंट प्रोडक्ट्स फॉर्म हो रहे होंगे और क्या हो रहा होगा, वो रिएक्शन फास्ट ऑर्डर काइनेटिक्स को अगर फॉलो कर रहा है तो there is a chance, there is definitely a chance of formation of intermediate. Okay, then there is the fourth evidence, no substitution at bridgehead carbon. Okay, substitution reaction under SN1 reaction either do not takes place or proceed very slowly at bridgehead carbons. Okay, SN2 reaction also fails with these substrates though for different reasons. SN1 reaction proceed through carbocation, which must be planar. In the first session, we discussed about that in SN1 reaction, carbocation is formed, and that carbocation is planar. Okay, because of rigid case-like structure of the substrate, breeze-head carbon atoms can assume planarity. Hence, heterolysis leading to the formation of carbocation is also prevented. What this says, कि if the we are going to take the example, if SN1 reaction is found in breeze-head carbons. सो अगर SN1 रिएक्शन होगा तो क्या होगा, कार्बोकेटाइन फॉर्म होगा. तो कार्बोकेटाइन जो भी फॉर्म होगा उसको प्लानर होना पड़ेगा. बट ब्रीज हेड कार्बन में वो जो रिजिड केस लाइक स्ट्रक्चर होता है ब्रीज हेड कंपाउंड का, तो इसलिए वो जो कार्बोकेटाइन बनेगा वो प्लानर नहीं बन सकता. अगर वो प्लानर नहीं बन सकता तो SN1 रिएक्शन नहीं दे सकता. ओके, consequently breeze head carbons are resistant towards substitution by SN1 mechanism. Then this is the example where no reaction occur, because here the carbon is breeze head carbon and it has a rigid like structure. Okay, although analogous open chain system reacts readily. If this is going to be open chain structure, then it will react readily. Okay. However, if the rings are large enough, SN1 reaction should be possible because nearly planar carbocation may be expected there. If the ring size is very much large, then nearly planar carbocation may be formed and then SN1 reaction can be occur. Okay. 2,2,2 bicyclic systems undergo SN1 reactions much faster than smaller bicyclic system, though the reaction is still slower than with analogous open chain system. Thus, the following rate were observed for solvolysis in 80% aqueous ethanol at 25 degrees centigrade. This is an open chain system. It will react readily. This is a large large ring like structure, so it will give a slower reaction. It is a smaller ring, and here the carbocation which is formed, it will have the rigid like structure, so it will not give any SN1 reaction. So the rate is 10 to the minus 14, means almost reaction is not proceeding here. Okay, this is it. In the next class we are going to discuss about SN1 mechanism. Okay, thank you.